Okay, the question's on dinitrophenol, DNP. It's shown below. There's the structure. It disrupts electron transport. Both DNP and its conjugate base freely pass through the inner mitochondrial membrane. Which of the following processes would be most likely inhibited with DNP? And you're given oxidation of NADH, reduction of O2, ATP synthase activity, and oxidation of FADH2, all things which occur in electron transport. So think about electron transport, think about the answer, and the answer is C, ATP synthase activity. So here's the image that you should have in your mind about what electron transport is. You should recognize that what is occurring during the transport of electrons is that you have the hydride anion giving up electrons, which go to another carrier, and then you have the protons left over. Notice that the protons are kicked into the inner membrane space where you build up a proton motive force or a gradient. So what you see there is on one side of the membrane you have a lot of protons, on the other side you're relatively negatively charged, so you have a gradient, so you have potential energy. And we all remember that energy can neither be created nor destroyed, but it can be converted from one form to another. So the potential energy gradient made by the protons in electron transfer is coupled to the synthesis of ATP via ADP through the ATP synthase. So it's a coupled reaction. Now, if you have DNP, and what it does, it goes back and forth across the membrane. What happens is that as it goes from one side to the other, it's either picking up a proton and then it delivers the proton to the other side. And so what it's doing is it's dissipating that potential energy gradient. It's destroying the gradient. It's not preventing electrons from flowing through. And so if the gradient is destroyed, there's nothing to couple to ADP plus PI. ATP synthase activity is going to be down. Come see us at medpathway.com.